All right, guys, this is Mrs. Lyons, and now we are going to dig into all that we can do with stoichiometry. Okay, so it turns out there are several types of problems that we have done, or that we can do, excuse me. The first is mole-to-mole conversions, which are one-step problems. Those are what we've been doing, okay? We can also go from grams to moles. Okay, so this would be a two-step problem. Moles to grams would be a two-step problem. And grams to grams would be a three-step problem. Okay, so hopefully by the end of this video, you will be able to determine how many steps there are going to be in a problem and how you're going to go about solving those. Okay, when we have grams to moles, okay, we use the molar mass. Okay. When we have moles to moles, when we're doing a mole-mole conversion, we use the mole ratio. All right. In chemistry, we mostly use gram to gram problems or calculations because when we do a lab, we can't measure the number of moles. We don't have a scale that allows us to measure moles, but we can measure grams. And if you remember when we did mole airlines and the poisonous pill, we can convert between moles and grams of one substance. Okay, so let's look at what this looks like. Okay, now I want you to write something on your paper, and I call this the mole map. And basically, the mole map will help me figure out how many. The mole map starts with grams of A, which then we can convert to moles of A using the molar mass. We can then convert moles of A to moles of B using the mole ratio. And then finally, we can convert moles of B to grams of B, again, using the molar mass of compound B. Okay, so here's the thing that you have to think about. When we do stoichiometry problems, we're trying to figure out if we put this much of one substance in, how much do we have to add of a second substance, or how much product do we get? So we're always talking about two different substances. All right, so let's look at how this works. Again, you're always going to need to balance your chemical reaction. Okay. And this one also asks you for states of matter. So we know nitrogen is a gas, hydrogen is a gas. I don't expect you to know it, but NH3 is ammonia. It's also a gas. Okay. If we balance this a couple of times. I need to put a 2 here because I've got 2 nitrogen. 2 times 3 hydrogen is 6. So I go 3 times 2. So there's my balanced chemical equation. Okay. All right. So this says a lab tech needs 4.6 moles of NH3 for a lab and needs to determine how many grams of nitrogen gas is needed to complete the reaction. Okay, so my given is moles. My given is 4.6 moles of NH3. What I'm looking for is grams of nitrogen gas. So our equation is N2. Okay. Now, something that's important to note. Notice my mole map has grams of A, moles of A, moles of B, grams of B. In here, I don't have A's and B's. Okay, so it's almost like algebra, kind of, where we designate. So A for all of our problems is always going to be the substance in our given. So A is NH3. And then B is always, so A is always our given. B is always our unknown substance. Okay, so we're going to start by setting up our problem. So 4.6 moles of NH3. just like we've always done in the past. We're always going to start with that number over 1. Okay, now I want you to notice this, since A is NH3, this is NH3. So this is starting, if I look up here at my mole map, I'm starting with moles of A. Okay. I want to get to grams of B. All right. So B is N2. All right. And if I look at my mole map, I want to get to grams of B. So I'm starting with moles of A. I want to get to grams of B. Okay. Now, the way to determine how many steps this is, see each dash is a step. So this is going to be a 2-step problem. All right. The first step is going to be to go from moles of NH3, so moles of A to moles of B. So it's a mole conversion, just like we've done the last day or so. Okay, so in this case, our mole ratio, moles of A, so it's going to be 2 moles of NH3, and our B is N2, so to 1 mole of N2. Okay, so I'm going to plug in 2 moles NH3, 1 mole N2. Okay, so let's calculate that. So I'm going to have 4.6 divided by 2. So 2.3. So this tells me I have 2.3 moles of N2. Okay, so moles of NH3 cancel out. So basically this is telling us, okay, I want 4.6 moles of NH3. Okay, for every 2 moles of NH3, I need 1 mole of N2. So what that means is I need to start my reaction with 2 moles of nitrogen. Okay, step 2 then is to go from, see this is moles of B, to go from moles of B to grams of B. So a mole conversion. And I'm just going to start, here's my given, okay, in that for my mole conversion. Okay, in a mole conversion, remember, I need moles. So moles of N2. And we're wanting to get to grams. So I need grams of N2 on the top. Now, think back to when we were doing the poisonous pill. 1 mole of any substance is equal to the molar mass on the periodic table. Okay, so if you have a periodic table, why do I never have a periodic table at home? So if you have a periodic table, take a look, find nitrogen. The molar mass of nitrogen is 14.01 grams. All right, remember we've got 2 of them. So I need 2 times 14.01. 1 mole is going to be equal to 28.02 grams. My moles of nitrogen are going to cancel out. So if I do that math, I still have that number in my calculator. 2.3 times 28.02 equals 64.45 grams of N2. All right. All right, let's flip this over and do another example. Okay, same equation, so our coefficients are the same. So 1, 3, 2, gas, gas, gas. Okay. So I'm gonna draw my mole map up here again. Remember, I can start, and I'm gonna even abbreviate it less, or abbreviate it more. I'm gonna write less. Grams of A, moles of A, moles of B, grams of B. All right. Now, just to note, okay, when you're going from grams to moles, you're always going to use the molar mass. When you're going from moles to grams, you're always going to use the molar mass. All right. When you're going from moles of one substance to moles of another, you're going to use the mole ratio. Okay. So that should help you just with when we're looking at those steps to know what you need to do. All right, so let's see. If, the lab tech has 30.76 grams of hydrogen gas, how many moles of NH3 can they produce? Okay, so if we look at our mole map, okay, let's write down our given first. So our given is 30.76 grams of hydrogen. Remember, it's H2. You got to look at your equation to make sure you have the formula of the substances correct. All right. And then we're looking for moles of NH3. All right. Again, let's define A and B. A is our given substance, so A is hydrogen. B is our unknown, so B is NH3. Okay. So if we look at our mole map, we're starting at grams of A. Okay, so we're starting here. And we want to end up with moles of B. So we're ending here. So look at the dashes. There's 1, there's 2. Okay, so this is going to be a 2-step problem. All right, so let's set it up. First step is going to be to go from grams of A to moles of A. So we write down our given, 30.76 grams. A is hydrogen, so H2 over 1. Okay. Now, we always know that our units, whatever units we have here, have to move down. Okay. So our first step is to convert from grams of A to moles of A. Okay. So I'm going to put grams of hydrogen down here on the bottom. And I'm using the molar mass to get to moles of hydrogen. Okay, so 1 mole, we know 1 mole is always equal to the molar mass on the periodic table. So the molar mass of hydrogen is 1.01. Remember, we've got 2 of them, so that'll be 2.02. Right? If we do that math, 30.76 divided by 2.02, 15.23. I'm going to round that, 15.23. Now, if you just leave this in your calculator because it's a 2-step problem and you follow math rules, YORO, you only round once, you can carry that through on your calculator. All right. So grams of hydrogen canceled out. I have my units here are moles of H2. Okay. That's how I start my next conversion. I start with moles of A. I want to get to moles of B using the mole ratio. All right. So moles of A is going to go on the bottom. A is H2. Moles of B is going to go on the top. B is NH3. All right. When you have mole to mole, you're looking for the mole ratio. So from our equation, 3 moles of hydrogen will produce 2 moles of ammonia. Okay, NH3 is ammonia. So now I've got my 15.23. I'm going to times 2 divided by 3 is equal to 10.15 moles of NH3. And there's our answer. And just to double check, moles of hydrogen cancel out. Okay, so that was a 2-step problem. Ooh, here we go. This So here's the next one. All right, the lab tech uses 54.2 grams of nitrogen gas. How many grams of NH3 can they be expected to make? Okay, so our given is 54.2 grams of N2. Our unknown is grams of NH3. Okay, is NH3. Okay, so to set this up, and I'm just going to write my little mole map right down here. What I can do, I can go from grams of A to moles of A, moles of B, moles of A to moles of B, and then moles of B to grams of B. You will be given this, grams of A to moles of A to moles of B to grams of B on the test. Okay, you'll have to know how to apply it. Okay, so we start with 54.2 grams of N2, okay, over 1. Now I know, since I have grams of N2 here, grams of N2 is going to go on the bottom, okay? We're going, so let's, I guess we didn't define, we're starting with grams of A. We're going to grams of B. So this, we're starting grams of A. We're ending grams of B. So if we count the dashes, 1, 2, 3, this is going to be a 3-step problem. Okay. So back to my units. Grams of nitrogen is on top, so I know grams of nitrogen has to go on the bottom, so it will cancel. And that means that moles of A go on the top. So moles of nitrogen. And that's just going to be 1 mole. Okay, because the molar mass of nitrogen, 1 mole of nitrogen has a mass of 14.01 times 2. Okay, so 28.02. All right, if I do that math, I get 54.2 divided by 28.02 gives me 1.93. And that's moles of N2. Okay. The next step is going to go from moles of A to moles of B. All right, so this is my given for that problem. All right. Now I know, because, so remember you guys, units have to cancel out, always. That's why when we look at this, we know that moles of N2 has to go on the bottom. And in this step, we're trying to get to moles of B, and B is NH3. So moles of N2 are going to cancel out. Now, we get these numbers from our balanced chemical equation. So 1 mole of N2 reacts to give us 2 moles of NH3. Okay. So then to do this math, we're going to take our 1.93 times 2, and that gives us 3.87 moles of NH3. All right. And then our last step is to go from moles of B to grams of B. So I'm just going to move this down here, 3.87 moles of NH3 over 1. So that it will cancel, I have moles of NH3 on the bottom. So if you remember, the problem is asking me for grams. So I know that I need 3.87 moles. I've got to convert that to grams. 1 mole of NH3. Uh-oh. 1 mole of NH3. All right, so we've got nitrogen. We've got 1 nitrogen. And we've got 3 hydrogen. Hydrogen is 1.01. So 3 of them is 3.03. If I add these up, I get 27.04 grams of NH3. So moles of NH3 cancel out. I'm going to take my 3.87 times 27.04, and I get, let's see, 104.61 grams. So here we go, 104.61 grams of NH3. That is our final answer. All right. All right, I'm going to go ahead and work through these that I want you to try. All right. Let's see. Oh, we are having, okay, so this gives you the reaction. You have to predict the products. Okay, so we have sodium plus chlorine remember that's going to be a synthesis reaction. And when we combine things, we look at the charges. So sodium forms a +1 ion. Chlorine forms a -1 ion. So this is just NaCl. That's a solid. Remember, sodium is a solid because it's a metal. Chlorine is a gas. Now we have to balance. Since we've got two Cl2s here, I need a 2 here. And then I need a 2 here and a 1 here. All right. So we've balanced our equation. And we're going to set this up. We are given 8.22 grams of sodium. And we're looking for unknown moles of sodium chloride, NaCl. I'm going to write my mole map right here really small. So grams of A, moles of A, moles of B, grams of B. Okay. So we are going, and then can I just do this? Can I just say A is sodium and B is sodium chloride? Okay. So we're starting at grams of A, ending at moles of B. So that's a two-step problem. Okay. All right. So we're starting with 8.22 grams of sodium over 1. All right. Grams of sodium is going to go on the bottom. All right. Okay, and we're going to moles of sodium. So moles of sodium is going to go on the top. This is the molar mass. Okay, so grams of sodium, we have to look at our periodic table, 22.99. So the molar mass of sodium, 1 mole of sodium has a mass of 22.99 grams. All right, so I'm going to do 8.22 divided by 22.99, and I get 0.35. I'm going to round that to 0.36. Moles of sodium. Okay, so that's step A. That's step 1. Step 2 is to go from moles of sodium to moles of sodium chloride. All right, so when I do this step, I need the mole ratio. Okay, so here I went from grams of sodium to moles of sodium. And now I want to go from moles of sodium to moles of sodium chloride. Okay, if I look at my balanced chemical equation, 2 moles of sodium will produce 2 moles of sodium chloride. So if I do that math, and I'm just going to start with my number, I'm going to times by 2 divided by 2. Guess what? I get the same number. So my answer, I'm going to round 0.36 moles. So moles of sodium canceled out, leaving us with moles of sodium chloride.